What do we do if we want to raise a number to a fractional power whose numerator is not 1? As an example shown here, if we wanted to raise x to the n divided by m power, we can rewrite that as x raised to the n power divided by x raised to the m power. Or we can write that again as the m root of x raised to the n power. Let's plug some numbers into these variables here and go over the example here at the bottom. If we take 4 raised to the 2/3 power, we can rewrite that as 4 squared divided by 4 cubed, or the cubed root of 4 squared. 4 squared equals 16, so we can write that again as the cubed root of 16, which our calculator will tell us equals 2.52. How would we multiply two numbers that shared the same base, but each were raised to a different power? In the example here, you can see that if we had a raised to the n power multiplied by a raised to the m power, that is the equivalent of a raised to the n plus m power. In the example here at the bottom, we will take some numbers and replace the variables in the example above with them. For the example, if we wanted to multiply 2 raised to the 3rd power by 2 raised to the 4th power, that would be the equivalent of 2 raised to the 3 plus 4 power, or 2 raised to the 7th. 2 raised to the 7th, we'll find out, is going to equal 128. How would we multiply two different numbers that were each raised to the same power? In the example using variables at the top here, we see that a raised to the n power multiplied by b raised to the n power can be rewritten as a times b raised to the n power. If we insert some numbers in place of those variables in the above example, where we have 3 raised to the 2nd power times 4 raised to the 2nd power, this can be rewritten as 3 times 4 raised to the 2nd power. 3 times 4 is 12, and 12 raised to the 2nd power equals 144. How would we divide two different numbers that were each raised to the same power? Using variables, we can write that as a raised to the n power divided by b raised to the n power. This can be rewritten as a divided by b raised to the n power. If we insert some numbers into those variables in the equation above, we can say that 4 raised to the 3rd power divided by 2 raised to the 3rd power is the equivalent to 4 divided by 2 raised to the 3rd power. 4 divided by 2 equals 2, and 2 raised to the 3rd power equals 8. If I wanted to raise a base number to a power and then raise that to a 2nd power, I would simply raise the base number to the product of the two exponents. As shown here, as an example, if I wanted to raise a to the n power and then that to the m power, I could simply rewrite that as a raised to the n times m power. Using some actual numbers in an example, I can show that 2 raised to the third power and that raised to the second power would be equal to 2 raised to the 3 times 2 power, or 2 raised to the sixth power. 2 raised to the sixth power is equal to 64. How do we add or subtract numbers in scientific notation? First, we adjust the powers of 10 in the expressions so that they have the same exponent. We do this by moving the decimal point of the number with the smaller exponent to the left or right and changing the exponent accordingly. Next, we add or subtract the coefficients, the numbers before the power of 10. Then we convert the answer to proper scientific notation with only one digit before the decimal and the power of 10. In this first example, we want to add the two numbers in scientific notation that have different exponents. We begin by taking the second expression, 1.7 times 10 to the negative 4, and converting that to 0.17 times 10 to the negative 3. By moving the decimal place one place to the left and changing the power of 10 from negative 4 to negative 3. That leaves us with 4.6 times 10 to the negative 3 plus 0.17 times 10 to the negative 3. We add the two coefficients together, 4.6 and 0.17, to get 4.77 times 10 to the negative 3. In the second example, we want to subtract two expressions. We want to subtract the second expression from the first expression. We will begin by changing the second expression from 8.89 times 10 to the fourth to 0.889 times 10 to the fifth. Again, by moving the decimal place one place to the left and changing the power of 10 to 10 to the fifth. We then end up with 5.64 times 10 to the fifth minus 0.889 times 10 to the fifth. We subtract the 0.889 from 5.64 to get 4.751, multiplied by 10 to the 5th. To change the root of a number expressed in scientific notation to proper scientific notation, first change the exponent if necessary so that it is divisible by the root. In our first example here, we want to take the square root of 4.9 times 10 to the third power. Taking the square root is the same as taking the second root. So we want to change our exponent so that it is divisible by 2. We will change the expression then to taking the square root of 49 times 10 squared. We do that by moving our decimal place one place to the left from 4.9 to 49, and then changing our power of 10 from 3 to 2. Then I can split that expression into two terms, the square root of 49 times the square root of 10 squared. The square root of 49 is 7. The square root of 10 squared is 10 to the 1 power, or 10. And so expressed in scientific notation, our answer would be 7.0 times 10 to the 1 power. In our second example, we want to take the cubed root of 1.25 times 10 to the negative 4. Our root is 3, so we need to change our exponent to a number that is divisible by 3. I can do that by moving our decimal place 2 places to the right to change 1.25 to 125, and changing the exponent of our power of 10 from a negative 4 to a negative 6. Then I end up with the cubed root of 125 times 10 to the negative 6. If I split that expression into two parts, I then end up with the cubed root of 125 multiplied by the cubed root of 10 to the negative 6th. The cubed root of 125 is 5. I find the cubed root of 10 to the negative 6 by multiplying the exponent, negative 6, by the root 3 to end up with a negative 2. My final answer then will be 5 times 10 to the negative 2.